Good morning, guys. Okay, before we get started, do you have any question? Okay, so we're gonna first of all we're gonna get to the review some of the things we talked about yesterday. We're gonna talk about the animation method. Let's review that really quickly. So let's go to the book. So we finished question number 1 yesterday. So let's look at question number 2. All right. So we get this system of linear equations, right? And then you're gonna solve for both x and y. I'll give you a couple minutes. Think about this. And this time, let's learn how to eliminate. Let's eliminate. All right, guys, let's go over the solution. So first of all, if you want to revise this, right? Because for the second equation, it wasn't written in a consistent way as the first one, so we can divide it. 7y48. Meaning you're gonna write minus 3x first, adding 5y equal to minus 24. Now right here, we want to eliminate variable x, right? So this one is 9, the other one is 3. So you're gonna turn 3 into 9 and multiply the second equation by 3. And once we do that, we'll end up with this. Carry over the first equation. And also, for the second equation, multiply by 3 minus 3x times 3 is minus 9x. 5y times 3, 15y. And then minus 24 times 3 is minus 72. And these two terms are opposite. If you add them, you offset them, right? So add two equations, 9x plus minus 9x, that's even 0. Minus 7y plus 15y, 15y minus 7y is 8y. And then minus 72 adding 48 minus 72 minus 48 that's 24. And from there, we divide 8 on both sides of the equation. Y is equal to 3. And once we get the y values, and then we can find the x values. And so we can use the first equation, right? So here, replacing y with -3, and we solve for x. And that x minus 7 times -3 equal to 48. And then that x plus 21 equal 48. And subtract 21 from both sides of the equation. That x equals 27. Now divide both sides of the equation by 9. We get a result. And x equals 3. For 3 and -3. We can also check it, right? We can check. Say plot the both numbers in the first equation, we get 9 times 3 minus 7 times 3. That should be equal to 48. So this is 27, adding 2 negative and positive, 7 times 3, 21. That turned out to be 48. 48. That means it's good, right? We satisfy the first equation. Second equation, we do 5 times 3 minus 3 times 3 should be equal to minus 24. 5 times 3 is minus 15 minus 9, that equal to minus 24. This is negative 24, negative 24. So it's a, yeah, this is good, right? Meaning it satisfies both equations, so the answer is correct. Any question about this? So it's 3 and -3. Okay. Also, I checked your homework progress, right? I noticed that a lot of you guys didn't do too much homework. Okay, you need to score 70%, right, on our homework in order to pass the course. So you can't pass the course without doing the homework, right? That's the thing, even though you pass the final. So make sure you do all your homework with a minimum 70%.
I have a question.
Yep, sure.
For some reason, my username and password is not working no more.
Oh,
And I don't know why, because you said it's just like the first letter of your first name and your last name and then your
yes.
CUNY code.
That's right, Bianca. So let me quickly
It
double.
keeps telling me that my authors it failed. Like,
Your last name is um, yeah, here, Bianca.
yeah.
Last name is Becandie, and then CUNY
Mm-hmm.
number is this.
Mm-hmm.
It doesn't work. Maybe you should be using this username. Becandie.
Okay, so the B cannot be uppercase.
No uppercase, everything lowercase.
All right.
So try that. It should work.
Okay, thank you.
No problem. So yeah, so make sure you do your homework, right? With the minimum 70%. So if let's say you did a homework, you get 70%, and theoretically you can move on, right, to next one. But obviously, if you can get better score, that's definitely what helps. So make sure you do your homework before the last day. Don't accumulate too much work, right? You should try to knock it out every day. Maybe in the morning we have a class. In the afternoon, maybe do some homework, right? Do all the homework which is due by the next by the next day. So to catch up with the progress. Again, this is crucial, right, for you to pass. All right. So let's look at question 3. So let's go back to question 3 here. All right. So now let's take a look at this question here. I'm gonna show you how to simplify this first you know before you jump into the solution process. So first of all, if you see anything like this, right? Because they all in a fractional form. Um, so one way to do this is turn everything into a whole number by using the LCD, right? So the LCD for the first equation will be 2, 7, 14, right? Will be 14. For the second, for the bottom part, LCD is 21. So for the first equation, you will multiply everything by 14. Okay. Second
You're not
equation,
sharing your screen, Professor.
right? Yes, I forget. And thanks for the reminder. Yeah. Okay, so here goes. So we need to figure out the LCD for the top first equation, and for 2, 7, 14, LCD is 14. And for 3, 7, 21, and the LCD is 21. So for the equation on the top, you multiply by 14. Equation on the bottom, we multiply by 21. So now x over 2 by 14, right? X over 2 by 14. We turn 14 into a fraction. We'll go into 14 7 times. So we get 7x over 1, so it's 7x. So now we turn into the equation with the whole number, right? So we don't have to deal with the fraction. And the second one, y over 7 times 14. 7 going 14 2 times. 2 times y on top. 1 times 1 on the bottom, so 2y. And that is the third one will be minus 13 over 14 times 14. 14 get cancelled. We get negative 13 over 1, negative 13 on the right hand side, negative 13. Okay, very similar for the second equation. So x over 3 times 21. So make 21 a fraction. 3 going to 21 7 times. Yeah, 7x over 1, right? So which is 7x. to be 7x again. And then the second one, y over 7 minus 21. 7 going to 21 3 times. We get 3y over 1. And that will be 3y. So the 3y here. And last one is negative 16 over 21 times 21. And 21 get cancelled. Get negative 16 over 1, which is negative 16. So this is negative 16. And now these two equations, now we don't have fraction anymore. So if you subtract the two equations, and we are eliminating variable x. X is gone. You subtract it because 7x minus 7x becomes 0. So these two get cancelled. And then 2y minus 3y is minus 1y. And then minus 13 minus 16 is plus 16. So negative y equal to 3, positive 3. And now we divide both sides of the equation by negative 1. And 2 negative positive y equal to, this is plus minus is minus, 3 over 1 is 3. So y equal to negative 3. And now once we have this, one of the solutions here, you will plug into the, you probably don't want to plug into the original equation because they're all fractions. So you're going to plug into this, right? This equation here. So right here, so we get 7x plus 2 times negative 3. That is equal to negative 13. So 7x plus minus is minus 2 times 3 is 6, equal to negative 13. As fixed from both side equation and cancel that 7x equal to 6 minus 13, that's negative 7. And we divide both side equation by 7. And that's equal to negative 1. So negative 1 and also negative 3. Any question about this? All right, so yeah, let's go back. Negative 1 and 3. They go good, right? I'm gonna give you a new question here, and you guys can try this. So I'm gonna write out the equation here quickly. So let's say you have something like f(x) plus minus 1/3 of y equal to 2. First equation, second equation, 4x plus 2/3 of y, and that is equal to 6. Then you want to solve it, right? Let's try it.
You're not sharing your screen.
Yeah, okay. Here you go. And thanks for the reminder. And I forget. And let's go over solution. For top equation, the LCD is 6. First equation, 2 times 3 is 6. On the bottom, the second equation, the LCD is going to be 12, or 3 times 4, that's 12. So we multiply the first equation by 6. You multiply the second equation by 12. All right, so let's simplify this. So half x times 6, 3x. And then 1/3 of y times 6 minus 2y. 2 times 6 is 12. And then quarter x times 12 is 3x. And 3 over 2y times 6 times 12. 2/3 of 1. Now look. 2/3 of y times 12. Okay, so 3 going to 12 4 times. And we end up with the 2 times 4 y, ay over 1. So ay. So let's go back here, ay plus ay equals 72. So now we're gonna, because we have 3x here, both terms are the same, so if we subtract it, subtract the two equations, we'll get the, we'll eliminate, so get rid of x. So subtracted 3x is cancelled, minus 2y, minus plus ay, minus 2y, minus ay. 4 minus 72, that's 60, minus 60. And then minus 2y minus ay is minus 10y, negative 60, and we divide both sides of the equation by negative 10. And so that's y is by itself, 2 negative 10 is positive, 60 by 10 is 6. All right, so now once we figure out the y values, then we can solve for the x values. To plot this number into, plot the y into the first equation. Plot into the first equation. So we get 3x minus 2 times 6 equal to 12. So 3x minus 12 equal to 12. And we add 12 from both sides of the equation. 3x equals 24. And from there, let's divide both sides of the equation by 3. And so the 3x equals to 8. So x8, y6. Right? Any question about this? Okay, so no questions, right? Let's go back to, so I'm going to show you another method called substitution method, which is section 1.3. So let's look at it right now. I'm going to open the OneNote. Yep, so let's move on to section 4.3. A substitution method. So section 4.3, it's on substitution method. For example, let's say we have a system of linear equation, x plus y equal to 2. The other equation is y equal to 2x minus 1. Okay, so if you look at the second equation, y is already by itself. So that means we can utilize this kind of a special setting. So we will just F is right. So in the first equation for the y, you will replace that with a 2x minus 1. So by doing this, we eliminating the variable y in the first equation. But still, right, we still try to eliminate one of the variable by using a different approach. In this case, we utilize the second equation to get rid of one of the variables in the first equation. So going back here, we plotting the replacing y with 2x minus 1 on the first equation, we get x plus 2x minus 1 equal to 2 from the first equation. But now we only have a one variable and we can solve for x. This is 1x plus 2x, 3x minus 1 equal to 2. And add 1 from both sides of the equation. And 3x equal to 3. And from there, we just divide both sides of the equation by 3. We get x value equal to 1. And once you find the x value, then we can find the y value, right? So going back here, we replace x with a 1, solve for y. We get 1 plus y equal to 2. And subtract 1 from both sides of the equation, y equal to 1, 12. So x equal to 1, y equal to 1. Any question about this? This is what we call the substitution method. Let's look at a little bit more sophisticated examples, right? Let's say you have something like x minus 3y equal to -1, and then 2x minus 3y equal to 4. Now, we could definitely use the elimination method to do this, but let's try to use substitution method, right? So we're going to work with the first equation here. So in the first equation, let's take out that first equation. Let's get x by itself by adding 3y from both sides of the equation. Now, as you can see, x equal to 3y minus 1. Now we're going to take this thing, minus 1, and then plug back into the second equation. And once we do this, then the variable x will be eliminated, right? So by using the substitution method, we get rid of one of the variables here. So once you plug in the x with a 3y minus 1, we're going to get 2 times 3y minus 1 minus 3y. That should be equal to 4. And then we distribute no more x, only y left. So 2 times 3y is 6y. 2 times 71 is added 2 minus 3y. That is equal to 4. Now the combined like terms, right? 6y minus 3y, that's 3y minus 2 equal to 4. And from there, we just add 2 from both sides of the equation. Cancel the 2, 3y equal to 6. Now divide both sides of the equation by 3, y equal to 2. And then once we have the y values, then we can find x value because we're going to plot back into here, right? And so x equal to 3y, 3 times 2 minus 1. So 6 minus 1, that's 5. So 5 and 2. And we can check it if we want to, right? So let's check it. And plug into the first equation, should be 5 minus 3 times 2. That's equal to -1, right? 5 minus 6, it is -1. So this is good. -1 equal to -1. To satisfy the first equation. And second equation, 2 times 5 minus 3 times 2. That's equal to 4, right? It's 10 minus 6. That's indeed 4. 4 equal to 4. It's good. So that means we have the correct solution, right? Any question about this? Right, what if we have something like this, right? We may have something, some kind of question. I'll show you some of the other questions. Another type of question. So let's say y equal to 1.5x plus 15, and then y equal to 0.75x plus 30. So we end up with something like this. And let's say we want to use the substitution method. So here we're gonna take this thing. Since y is equal to this, so going back to second equation, replacing the y with that. Now in that case, we eliminate the variable y. So 1.5x, 15 equal to 0.75x, and 30. Now from here, we can solve for x. No more variable y. First of all, minus 0.75x, minus 0.75x. Cancel that 1.5x minus 0.75x is 0.75x. Adding 15 equals 30. Now subtract 15 from both sides of the equation. Cancel that 0.75x equal to 15. And then we divide both sides of the equation by 0.75. We cancel 0.75, x is by itself. And let's do it, right? Let's do the long division. So I'll move the decimal 2 units to the right, make it 75. So we are increasing the divisor 100 times. Same thing for the dividend. Right? Putting a couple zeros and then move the decimal to the right. You get 1500. Now 75 going to 150 two times. And 75, 150 divide evenly, copy that zero, putting the quotient x equal 20. And then once you have the x value, then we can plug into the either the first or second equation, or we can plug into the second equation. We get the y equal to 0.75 times 20, adding 30, and 0.75 times 20, that's 15, and 30, y value equal 45. 20 and 45. Any question about this? Okay. Now let's get to the exercise from the workbook. 4.3.
Hey, Professor, did you do attendance?
Not yet. Not yet. I'm gonna do it soon. Yeah.
Okay.
All right. So substitution method. Okay, let's look at the first question. Right? You guys try this one. While we're doing this, I'm calling attendance. About Marion, are you here?
Here.
Okay. So, let me just get this one. So let me screenshot this. 1 second. Share this screen. And Alessandra.
Yeah, here.
Okay, okay. Bianca is here, right? Mirza.
Here. Here.
Okay, I got you, Mirza. Ashley.
I'm here.
Okay, great. And Benjamin. Benjamin. Kareem.
I'm here.
Okay, good. Anahi.
Here.
All right. Maya.
Here.
All right. And Sarah.
Here.
Okay, great. Jonathan. Here. Anta.
Here.
Good. So I'll mark everybody in attendance, right? Okay. let's go over this. So first of all, we use first equation. In order to use the substitution method, you need to get x by itself. So we take the first equation and then solve for x. -3y minus 3y. Cancel that x is by itself. We get -3y minus 1. So now we get that. And from here, right, you're gonna take this and apply it into the second equation. Replacing x with a -3y minus from the second equation. So it's 7 times 3y minus 1 plus 5y. That's equal to 9. Then we can distribute it. 7 times -3y is -21y. 7 times -1 is -7 plus 5y. That is equal to 9. Combine those two, right? -20y plus 5y. 5y minus 21y is -16y. And 7 equal to 9. So that's 7 from both sides of the equation. Cancel that -16y equal to 16. We divide both sides of the equation by -16. Cancel that. Y is by itself. Plus minus is minus. 16 by 16 is 1. So y equal to -1. And once you have that, then we're going to find out x value. X value equal to -3. Y is -1 minus 1. So it's 3 minus 1, that's 2. So x equal to 2. So the answer is 2 and -1. Any question about this? So yeah, so we solve it. And let's look at the next problem. Yeah, this is and let's try this one. Solve this using substitution method. Let me give you a thought. But first of all, let me share the screen. Here you go. Now let's think about this, right? Let's say, let's rewrite the equation way. We get -4x plus 3y equals 22. And the other one is 3x plus 2y equals 2. Now, in order to use the substitution or elimination method, we probably want to do this. We probably want to turn both of them into the same terms, right? Same variable term in terms of y. So in the first equation, I will multiply by 2. Second equation, I will multiply by 3. And once we do this, we get -ax plus 6y equal to 44. And the other one is 3 times 3x, 9x plus 6y equal to -24. Now think about this, right? So we want to get y by itself. Okay, so in the first equation here, we're going to solve for 6y. So we get -ax plus 6y equal 44. Now we will do adding ax from both sides of the equation. Okay, and get 6y equal to ax plus 44. Now, second equation also have 6y here, right? So now you're going to pack this, replacing the second one with this. So the whole 6y becomes ax plus 44. So going back to the second equation, now with the 9x plus 8x and 44 equal negative 24. So 9x plus 8x is 17x plus 44 equal negative 24. We subtract 44 from both sides of the equation. Then we get 17x equal to negative 68. And divide 17 from both sides of the equation, x equal to negative 4. So figure out the x values. Now if you go back, you can go back to any original equation and replace x here with a negative 4. We have 3y minus 4 times 4 equal to 22. 3y adding 16 equal 22. Subtract 16 from both sides of the equation. 3y equals 6. Divide 3 from both sides of the equation, y equal to 2. So x equal to negative 4, y equal to 2. So that's how we solve it. We solve this. Any question about this?
Is that a 8 at the bottom on the left? We divided 17. 17x equals 8.
Minus 68 over 17.
Minus 60. Okay, thank you.
Minus 68 by 17. It is 4. It's so basically that's how we solve it. Here we do not take the conventional method because if you get y by itself, we're gonna get fractions, which is not good. We don't want to deal with fractions in this kind of settings. But again, if you probably it's easier to solve this using the elimination method, but a substitution method also is available. They are equally good. Okay. Let's go back and let's look at the next question. What time is negative 4 and 2? X negative 4, y equal to 2. Yep, oh good. All right, you guys try this one. This one it's not too bad. So yeah, give it a shot. Try it. And let's go for the solution. From the first equation, you will need to solve for y. So ax minus y. And this is the easiest way to do it, right? Because if you work on the second equation, then deal with the fractions and everything. It's the best way to solve it. Okay. So minus ax minus ax. Yeah, and I cancel that to get minus y equal to minus ax plus 19. Now we divide -1 across, right? What's left and right? Negative y over -1 is y. 2 negative to positive, a over 1 is ax. Plus minus is minus 19 over minus 19. Now we're going to plug this and plug into the second equation. We get 2x plus 3 times ax minus 19 equal to -1. So distributing and then combine like terms 2x plus 3 times 8x, 24x. Plus minus minus 3 times 19 is 57. 5. Now combine those two. So 2x plus 24x is 26x minus 57 equals 5. Now that is minus 5. Minus adding 57, right? Both side equation. And so that 26x equal to 57 minus 5, that's 52. And divide 26 from both sides equation after that. And so there's x is by itself, 52 by 26, that's 2. Now going back here, replacing x with 2. Now we're going to get y values 1, 2, 3 times 2 minus 19. Y equals 16 minus 19 minus 93. 2 and any question about this? 293. That's the answer. Yeah, both correct. All right, one last question, and we're gonna move on to the next section. Let's try this one. That second equation, y is already by itself, so that's the best. Okay. Yeah, try it. Okay, let's go to the solution. So in the second equation, y is already by itself. So just replace the y with a 3x, adding 5 in the first equation. And now the 2x plus 3 times 3x plus 5. We distributed 2x plus 9x plus 15 equal to 4. Now 2x plus 9x is 11x, adding 15 equal to 4. Subtract 15 from both sides of the equation. So that 11x equal to -11. Now divide both sides of the equation by 11. And so that x is by itself, we get -1. And from here, then once we get um, the x values, and replace x here with -1, right? So y equal to 3 times 1 adding 5. Y equal to -3 adding 5. Y equal to 5 minus 3, 2. 31 and 2. Any question about this? Okay, so it's the correct answer. Now the next section is about the application of this. So there's some type of problems we're gonna deal with application of the linear equations. I'll show you some examples first. We have different type of problems. First one is called a number problem, and second one is called an interest problem. Right? So we have application 4.4. It's on application. First one is a number problem. Second one is what we call the interest problem. And so let's see any good questions from your system. 4.4 application. So several questions here. This is a number problem, a ticket problem, and a coin problem. Very good. So let's start with the number problem. First one. So let's say the number y is a less than 4 times another number x. The sum is 27. Let's see how we solve this. And this is a very typical number problem because deal with the two different numbers. You know, try to locate the value of each number. So already give us the variable term, right? Y and then variable x. And first of all, for the variable y, this means, so we're going to set up equation with the number y is equal to a less than 4 times another number x. 4 times another number x is 4x. A less minus 8. So that's a relationship between the number y and the number x. And then we express that in terms of the equation, right? The linear equation. And then second one is the second condition. So this is the first condition. Second condition is that sum is 27. That means x plus 7, x plus y equals 27. Right? So basically we are dealing with a system of linear equations and we try to solve for the x and y. Okay. Now I guess I'll let you guys try this, right? Because now you can solve using the method you just learned, right? We can do the substitution method to get a result. Okay, I'll let you try really quickly. All right, let's go over the solution. So first of all, we're gonna plug this. And then plug into the second equation. So y becomes 4x minus 8 in the second equation. X plus 4x minus 8 equals 27. X plus 4x is 5x minus 8 equals 27. Now add 8 on both sides of the equation. And so that 5x equal to 35. Now divide both sides of the equation by 5. So x equals 7. Now once you figure out the x, replace the x with 7 here. So the y value equal to 4 times 7 minus 8. 4 times 7 is 28 minus 8 divided by 20. As you can see, if you add 20 and then 7 is 27, right? So satisfy the second equation. And also, this 20 is a less than 4 times of the 7. 4 times the 7, 28. A less minus 8, that gives us 20. So that actually satisfy both equations. So x equals 7, y equals 20. Any question about this? 7 and a 20. Yep, they both correct. Okay, let's take a look at this one, right? You can try yourself, right? This time I'm gonna let you set up the equation yourself and then solve it from there. Okay, guys, let's go over the solution. So this value is 2 times a smaller number. Value 2 times a smaller number is 9 more than the larger number. So let's assume larger number as y. So a smaller number as x. 2 times a smaller number, 2x, right? Is means equal to 9 more than y, right? Larger number is y, so it's y. That's first equation we set up. Second equation, the difference is 2. If you're using the larger number minus smaller number, that'll be 2. So here, and then we can basically solve for x and y, right? Okay, so let's work on the second equation here, and then get y by itself. So add x on both sides of the equation. Now cancel that, y equal to 2 plus x. Now once you get that, I'm just gonna plug this into the first equation, and then we're gonna solve for x. So 2x equal to 9 plus 3 plus x. Combine them, we get a 2x equal to 11 plus x. Now from there, subtract x from both sides of the equation, x equal to 11. And once we know the x, we know the y, and replace x with 11, the y value for 2 plus 11, that is 13. Okay. Yeah, the difference is 2, right? So that means you can also check it using those in both equations. But yeah, so the basically smaller number is 11, larger number is 13. Any question about this? Yeah, they were good. Okay. Now the second type of problem is called ticket problem. So let me show you how to set up the ticket problems. Let's just solve for the equation in a second. So a total of 950 tickets were sold. Again, a total of $3,370. So basically, there are 2 types of tickets, right? And first one is a quantity sold. Okay. The second one is the revenue, right, or the dollar amount. Dollar amount. I have 2 types of tickets, right? Adult ticket is $5 each. And I also have child's ticket, it's $2 each. So we're gonna assuming, so first of all, we can assume we have X amount of the adult tickets sold, and then we have a Y amount of the child tickets sold. So this is some kind of a assumption we can have, right? We can make assumption using a variable X and Y. And then for all the X tickets sold for the adult group, the total dollar amount will be $5 times X tickets, right? So it'll be 5X. And then for the children's ticket, $2 piece, and we are selling Y amount of tickets, so 2 times Y. And there are 2 conditions. First one is the total amount of tickets, 950 tickets. That means if you're adding X and Y, adding these 2 total tickets, we get 950 tickets. And the total dollar amount sold is 3,370. So that means 5X, 2Y should be equal to 3,370. Now from here, we can solve for each variable, right? Since we learned the substitution method, so here I'm gonna use the first equation, and then we can get either X or Y by itself. Let's say we want to get X by itself. So you're gonna substitute Y from both sides of the equation. which equal to 950 minus 1. And then you're going to take this and plug into the second equation. Here, then we'll be able to solve for y. We get a 5 minus 50 y plus 2y equals 3,370. And from there, now we can solve for y, right? So distribute it first. 5 times 950 will be 4,750. 5 times negative y is minus 5y. 2y equal to 3,370. Now combine the variable term minus 5y plus 2y, 2y minus 5y minus 3y, adding 4,750, that gives us 3,370. Now you will subtract isolated negative 3y minus 4,750 from both sides of the equation. Cancel that, minus 3y equal to negative, right? And then the 8 here, 5 here, right? So minus 555. So 4750 minus 3,370. Get a borrow one, so you get the, so there'll be 6 years, so this is not right. So get a 15 minus 7. That's 8. Minus 6 minus 3, 3. 4 minus 1 is 1. So it's minus 1,380. After that, we could divide negative 3 from both sides of the equation. We cancel negative 3, and then y is by itself. Two negative 10 to positive, right? So 1,380. 3 going to 12, 13, 14, minus 3, 12. Going down to 8, 3 going to 18, 6 times. Then that's 18, evenly divided. And you're going to put a 0 in the quotient of 460. So y value is 460. And once we know the y value, then we know the x value. We plug this 460 into this. So x equal to 950 minus 460. That turned out to be 490. So so 490 adult tickets are sold, right? And then 460 of children tickets are sold. Is 490, 460. Any question about this? $490 adult tickets, and then 460 children tickets. If add them, it's end up with 950 submitted. Yeah, they both correct answers. Okay. Let's look at next type of question. So this is the alcohol solution. I let you guys try this, right? Give it a shot. Or maybe let me set up the equation first. for you, and then you guys can solve it later. Right? Okay, so here, how many gallons of 80% of alcohol solution? Let's assume X gallon, right? And 40% alcohol solution, that's assuming Y gallons. Okay. What for that? And must be mixed to get 16 gallons of the 55% alcohol solution. If you combine those two, right? X plus Y is equal to 16 gallons. Eventually, we will get 16 gallons of alcohol solution. And also, we want to figure out the actual amount of alcohol, right? So you multiply 80% by X, you get alcohol from the first type, right? For first set of the solution. And then also, if you multiply 40% by Y, you get the alcohol concentration from the second type. And then the total alcohol should be 16 gallons times 55%. Yeah, because it's 16 gallons of 55% of alcohol solution. So we multiply that 16 times 0.55. I think it's 8.8, right? Yeah, let's double check. 16 times 0.55. It's 8.8. So basically we get this equation here. So we're turning all this percentage into a decimal numbers first. So X plus Y equals 60, carry over that. 80% becomes 0.8. 40% is 0.41. And 16 times 0.55, 55%. All right, and then I let you guys try this, right? Solve for this equation here. Solve for X and Y. We're assuming X gallons of 80% solution, Y gallons of 40% solution. All right, guys, next take a break, right? We're gonna finish the problems when we come back from the break. Take 30 minutes break. Come back at 10:45. Resume. Go back to this question. Let's finish the question. Right here, that's for the first equation, we will get either x or y by itself. Okay, so take out this, right? Y equals 16, and you just subtract y from both sides of the equation. Actually, you know what? This time I'm gonna get y by itself. It's easier than this way, so subtract from both sides of the equation. Y equals 16 minus x. And next up, we're gonna replace for the second equation, replace the y with this. We get 0.8x, 0.4 times 16 minus x. On the right hand side, 8.8. And then we distribute it by like terms, 0.8x plus 0.4 minus 0.4x equal to 8.8. Now again, combine like terms. Those who are like terms, 0.8x minus 0.4x plus 6.4 equals to 8.8. And we subtract 6.4 from both sides of the equation. 0.4x equal to 2.2. Very last step, divide both sides of the equation by 24. And so that's equal to 2.4 by 0.4. It's equivalent to 24 over 4, which is 6. So x equals 6 in 6/7 of 80% alcohol solution. And once you find out the x value, then we can find out the y value from the initial equation. So 6 plus y equals 16. Check 6 on both sides of the equation, then y equals 10. And gallons of 40% alcohol solution. 6 and 10. Okay. Any question about this? Okay, 6 and 10, got it. That's a meeting. Yep, they both good, right? Both correct answers. And then very last question, I'm going to move on to, it's about coding questions, right? Again, let's learn how to set up this type of coding programs. Okay, now we're going to move on to, after this, we finish chapter 4. I'm going to start on chapter 5 on the exponents and polynomials. Let's finish this question really quickly. So let's say Bob has two type of coordinates, right? We have dimes and nickels. Yeah, so set up this table to understand it, to visualize everything. So the first one again is quantities, right? That's assuming the second one is dollar value, dollar amount. So that's assuming has X amount of dimes and Y amount of nickels, right? Each dime is 10 cents. Okay. Now, the reason why I turn it into cents because it's easier this way because when we use cents, then we only deal with the whole numbers. If you're using, let's say, $0.1, right? Using dollars, then we have to deal with the decimal numbers. So that's why I decided to use cents. And then nickels is 5 cents a piece. Now, if you look at, if you have one dime, you get 10 cents, right? have a 2 dice, that will be 20 cents. If you have 10 dice, that's a 10 cents times 10, that's 100 cents. Okay, so X amount with 10X, right? So 10X. And then for the nickels, it will be 5 cents a piece. We have Y amount, 5Y. Now we can easily set up two equations. First one is a quantity, right? If you're adding X dice and then Y nickels, you get total coins, it's 42 coins. Bob has 42 coins. And then total dollar amount, meaning 10 cents, 10X plus 5Y. That is equal to $3.10. That's 310 cents. And that's 300. Okay. Now, we can solve this using either, I let you do it, right? This time I want you to solve using the elimination method. Yes, solving. Elimination method. We haven't done elimination method for a while, so let's use the elimination method to solve it. I'll give you some time to try that. I'll go over solution in a second. Okay, let's go over the solution. So here I'm gonna eliminate the variable x. So I'm gonna multiply the first yes, I'm gonna eliminate variable x. So multiply the first equation by 10 because second one is a 10x. The new system 10 times x and x 10y equal to 42 times 10 to 120. Minus 10x divided by equal to 310. Now we subtract it, right? Because they are exactly the same. 10x to cancel. The 10y minus 5y is 5y. 420 minus 310, that's 110. Now divide both sides of the equation by 5. So y equal to 22. That means we have 22 equals. And once you have that, let's plug back into the first equation. And let's solve for x. So x plus 22 equals 42. I subtract 22 from both sides of the equation. That's equal to 20. 20 dies and then 22 nickels. 20 dies is $2, right? 200 cents is $2. 22 nickels is 110 cents. That's $1.10. When you combine them, you get $3.10. Total is 42 coins. So that means it's good. So get up 20 dimes, 22 nickels. Any question about this? So we're going to check the answer here. Oh, good. Okay. So we basically finished chapter 4. Now let's take a look at the chapter 5. Let me give you some introduction on chapter 5. And chapter 5, it's mainly about exponents and polynomials. Let me share the screen. Chapter 5. Exponents. And then polynomials. So let's start with the 5.1. Multiplication with the exponent. Basically, we multiply the exponent. Start with a very simple foundation of the basic stuff is like if we have 5 squared, this is a typical exponent. So you're going to expand it, right? Meaning we multiply 5 2 times. Okay, 5 times 5. Straightforward, right? Now, what if we have negative 3 to the 4th power? Then very similar, right? You're going to multiply negative 3 4 times, right? Yeah, so 2 negative turn into positive. 3 times 3 is 9. 2 negative turn into positive. 3 times 3 is 9. And then 9 times 9 is 81. Now, but what if we have negative 3 to the 4th power? What do you think? Is it the same as that? Anybody want to share your thought on this? Okay, no problem. So you carry over the side, then you're going to expand it 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. So it's negative 9 times 9. Now 9 times 9, 81. So this is negative 81. So this is very, very important, right? A lot of students make mistakes here. They thought these two are the same, but they're not, right? You end up with the exact opposite result. This is something about exponent. Now let's talk about the properties. with respect to polynomials, right? Property number one, if you multiply two exponents in the same base, that's the x to the a times x to the b. Notice that same base, right? This is very important. And keep the base, you add exponent. So you get x to the a times x to the b equal to x to the a plus b. That's very easy to confirm this, right? I'll check this. Let's say 2 to the second, right? And 2 to the third. It should be equal to 2 to the fifth. Let's see, 2 to the second is 4, right? And 2 to the third is 8. Multiply them, you get the 32. Now, if you expand 2 to the fifth based on the property, it will be 2 times 2 times 2 times 2 times 2. Now we get 4 times 4 times 2. And 4 times 4 is 16 times 2, that's 32. That's why this is adding, right? Adding those two powers, we end up the same result. So you can it's like kind of like verify this using any real number example. It's very straightforward to verify this. Okay. Now let's try some of the examples, right? I think we'll do 5 to the third times 5 to the, let's say 8, right? Now they have the same base, so we're going to keep the base 5 and adding 3 and 8. That's how you actually apply this property here to tackle some problems. Second one, let's say we have x to the 7, x to the 8, and again, same base, keep the base up and then exponent. So x plus 8 is 50, x to the 50. And so on, let's say we have 3 to the x and 3 to the y and 3 to the z. And again, same base, right? Keep the base, add those 3. So x plus y. Any question about this? Let's take a look at. Let me give you some problems you can work on. So you try this. It will be y to the second times y to the y to the 7, and y to this one, second one. A to the 4 times a to the 5 times a to the x. Okay, let's go over the solution. So the first one, keep the base y adding 2, 7, and then adding, right? So it becomes 2 plus 7 is 9. 9 minus 4, that's y to the fifth power. Second one, keep the base a, adding 4, 5, and x. It's 8, 9 plus x. So this is property number 1, right? Now let's talk about the property number 2. If you have an exponent raised to another exponent, then it becomes x to a times b. But we multiply the exponent from inside of parentheses and then exponent from the outside. And we can easily prove this, right? Let's say we have a 2 squared to the third power, right? This is actually same thing as 2 to the second minus 2 to the second minus 2 to the second. And if you sum up this, it will be 2 plus 2 plus 2, 6. And then 6 comes from this. 2 times 3 is 6. That's why we come out the same result. Right? This is how you approach this, how to interpret this using the real world example. Right? You're using the numbers. Okay. Any question about this? All right. Now let's apply this property number 2. We simplify some of the expressions, right? Example 1. Let's say we have the x to the fifth to the x to the third to the fifth. So it becomes x multiplied by 3 and 5. Get x to the 15. And second one, let's say we have 2x. So 2x squared to the third, right? So we will apply this power, right? Distribute this power to both terms, 2 to the third, and then x to the second to the third. And then x to the second to the third, 2 to the third is 2 times 2 times 2 is 8. And then x to the second to the third, by this property here, 2 times 3 is 6. So this is 8x plus 6. All right, so let's try a couple of questions. First one. Let's say we got a y to the second to the seventh. Second one, we get 3g cubed. Second power. Try it. Let's go over solution. So the first one, you do keep the base y and multiply 2 and 7 y to the quotient. And second one, distribute it first, 3 to the second times z cubed to the second. 3 squared, 3 to the second is 3 times 3, that's 9. And for the z, you multiply 3 and 2. So that's 9z to the 6. Any question about this? Let's look at property number 3. Let's say we had an x, right? X to the a, y to the b, and to the c power. Right? So basically, it will be times x, a times c, ac, and then y, b times c, so bc. So that's basically how we simplify this kind of the exponent. It's different base, no, it's not the different base. So let's look at some of the examples of the fathers. Right. First of all, let's say we have a 5x second power, and actually by default there's a 1 here, but we can omit it. It's okay. So distribute 2 to both 5 and x. 5 squared times x squared. 5 squared is 25 x squared. The next one, let's say we have 2x y squared to the third. Now again, distribute the power to every single elements inside of this parentheses. So 2 cubed x cubed y will be 2 times 3, 6. Now after that, simplify. 2 cubed is 8 x cubed and then y to the 6. And third one, let's see. What if we have something like negative a quarter x squared y cubed to the second power? Again, we apply this property, right? So distribute power 2 to negative quarter first, and then x squared to the second, y cubed to the second. And from there, we get a negative quarter square, the negative quarter, it's negative quarter. We know 2 negative to the positive. 1 times 1 is 1, 4 times 4 is 16. So the answer is 1 over 16. We get 1 over 16 here. The rest of them, 2 times 2 becomes 4. 3 times 2 becomes 6. And so 1 over 16 has actually 4 y to the 6. And let's take a look at this. Let's say we got a 2 y cubed minus 3 y squared. Now we'll simplify the first parentheses. So 2 cubed times y cubed times 3 times y squared. And 2 cubed is 8. It's ay cubed and 3 times y. Now we're going to multiply the number 3 times 8, 24. For y, writing at 20 and 3 times 2, 5. That's 24 times the other 5. Any question about this? Okay. Assuming we have this 2x squared y to the 5th. So basically, we need to learn how to apply multiple rules here. Let's start with simplifying this exponent first. I guess 3x to the fourth, 9 second. So we take one parenthesis at a time. For the first parenthesis, we can just split it as 2 cubed times x squared to the third, right? And y to the fifth to the third. The second one, 3 squared times x to the fourth to the second and y to the second. And after that, we simplify every single one of them. 2 cubed is 8. And x 2 times 3, 6. For the y, 5 times 3, 15. And 3 squared, 27. Times 4 times 2 is 8. That's the 8 and y squared. And from there, we just multiply 8 and 8, 8 and 27. 216. Right, 27 times 8. 7 times 8, 56. Carry over 2 times 8, 16. 16 and 5, 21. 16. And for the x, keep the base x, adding exponents, right? We multiply two exponents with the same base. For the y, keep the base, adding 15 and 2. So we get 216, and x to the 14, and y to the 17. That is the final answer. Any question about this? Okay. I want you guys to try some of this. So, first one, 3y squared. Second one, 4y. And third one, negative half. So third y to the fifth square. And fourth one, 3m squared m cube. Yes, the third times 2m cube in the second. Let's try this. Right, let's take a look at the answer here. So the first one, distribute the power 2 to the 3, base 3 and then base 1. And then 3 squared becomes 9 and 1 squared. And second one, 4 to the third, m to the third, n squared to the third. And then 4 cubed, that's 4 times 4 times 4, 64. It's m cubed. The n, you multiply 2 and 3, you get 6. And the third one will be negative half squared times x cubed squared times y to the 5th squared. Then we simplify negative half squared, 2 negative turn to positive. 1 squared is 1, 2 squared is 4. Then x 3 times 2 is 6. Y 5 times 2 10. So the answer will be quarter, x to the 6, y to the 10. And then the question, right? What question? Distribute the first 3 cubed m squared cubed n cubed to the third. And the second one, 2 squared m cubed squared n squared. And 3 cubed, that's 27. M 2 times 3 is 6. And 3 times 3 is 9. 2 squared is 4. 3 times 2, 6. N squared. I'll multiply 27 and 4, you get 108, 108. And for M, keep the base at 6 and 6. For the N, keep the base at 9 and 2. Now simplify afterwards. 108 M12 N to 11th. Any question about this? The next thing we're going to talk about is scientific notation. It's also kind of like exponent. So the scientific notation. Now we have something like A times n to r, right? And here A must be greater or equal to 1, less than 10, right? So A is a number between 1 and 10. It could be 1. 1 is okay. And R is an integer, right? R is an integer. Integer means, okay, let me just rewrite it. Typical integer look like this. Let's say from negative 10 and then negative 9, right? All the way 0, 1, 2, negative 1, negative 2, right? All these are integers. So this is a typical type of integers. Goes on both direction, right? Forever. This is a list of all the integers with many numbers, right? Standing in both direction. So let's say in order to turn a large number, we want to write. This is a very large number, 376,000 in scientific notation. So typical thing we will do this, right? We first of all write a 376,000, and put back the decimal. Put back the decimal point. Now we're gonna move the decimal to the left 3 units, 5 units, right? 5 units is proper one. And because when we move the decimal to the left 5 units, we get 3.76. And that's the number between 1 and 10. Right here, you can multiply by n to this power. Because we move the decimal to the left 5 units, that means you're decreasing the number 10 to the 5th times. Or you can say you decrease that by 100,000. Because we do that, going from this number to this number here, right? And then we gotta keep the balance, and that's why we multiply by 10 to the 5th power to keep the balance. And that's how we typically turn a scientific notation, turn a whole number into a scientific notation, especially large numbers. And let's look at this. Let's say you want to write 4.52 10 to the 9th power in expanded form. So to turn the scientific notation into expanded. Again, you write out the 4.52, right? And then add a 0 in back. Here I'm gonna add 7 zeros. Now you move the decimal because it's times 10 to the 9th power, that means you're gonna move the decimal to the right 9 units. So this is 3 units, 6 units, 9 units. Now decimal goes here. Now from there, we know that this answer should be 4, comma, 120. That means this is 4,520,000,000. That's how you turn the scientific notation back into the standard notation. Okay. Any question about this? Okay. Now, next thing, you guys try this, right? We turn this 4,745,7 0. Just and 0, 0, 0, 0. Turn this into scientific notation. Second one is a turn 5.33 times 10 to the 8th power into standard notation, into expanded form. Let's try this. And let's go over the solution. So first of all, we're gonna turn this into a scientific notation. So we're gonna write down this. Put back the decimal point. Back. So we're gonna turn. So we move the decimal to the left 3 units first, and another 3 units. Then we end up with a number 4.57. And that's what we want. That's a number between 1 and 10. And times 10 to, since we move the decimal to the left 6 units, then it will be times 10 to the 6th power. Any question? For 5.33, this, I'm gonna write out 5.33. Add 60 in the back. So it's not moving the decimal, right? 3 units, another 3 and 8, right? Right here. Now the decimal, so meaning we increase the number 100 million times. So that becomes 5, 3 zeros, 3 zeros, 533 million. It's 3 0 becomes it's a cofactorial subdivision. Every 3 0 we get 1,000. Any question about this? Now let's go back to the formal system. Let's try some of the questions here. Go back to section 5.1. We all 5.1 right now. Multiplication with the exponent. Let's try question number 1, right? You guys try it. 81 k to 24, and you want to turn into a perfect square. Okay. See if you can figure out this. All right, let's go to the solution. So first of all, you're gonna turn 81 as 9 squared. And then k to the 24 will become k to the 12 the second. Now they both have a perfect square, right? So you put 9 and 12 together. Okay. So the answer is 9k to the 12 raised to the second power. And you can expand it, right, to double check. You get back to 81k to the 24th. Any question about this? Nice. A to the 12. Submitted, is correct answer. Okay, let's look at the second one, right? We try really quickly. And let's go over solution. So it will be c to the 6, right? It should be a power c to the 6 and f to the 6. So that's the answer, c to the 6, f to the 6. It's fairly straightforward. Okay, next one. And this one is really more complicated. You try this really quickly. Let's go over the solution. First of all, we carry over the 5 and then distribute the power into the second, t to the second, and get e3t the second. And from there, we're going to simplify. We've got a 5 times 100, e to the second, and e to 3t. Now we're going to multiply 3t by 2. The 3t times 2 gives us 16. 2 times 3 is 6. I'll get it. 5 times 100 is 500. T squared times e to the 6t. So you're going to put a 500 as a coefficient t squared times e to the 6t in the second box. So 500 goes here. T squared times e to the 6t. Okay. And let's do it. Right? So what? T squared e to 3t. Maybe they don't want this. You should rewrite the expression as a product. Okay. 10 squared is 100, 100, t squared, 3t times e. We write a following expression as a product. Neither factor could be constant. The answer is correct. Maybe just the way how we input it. It doesn't recognize this. So maybe that would flag 60. Maybe they want this. Let me try this. T e times e to 3t. The second power to the second. No. Oh, I see. They want to separate the e. Okay. I know what happened. So here e actually is a constant. So they want us to do this. After we do this, this is the correct answer. The only thing is we gotta separate e squared and then e to the 6 because e is approximately 2.718, 182. Right, so they want to separate e to the 6 and e to the e to the 6, e to the t squared, right? So going back here, we need to redo this. We're going to treat e cubed as a constant. It is a constant, actually, just not in the numerical form, but it's a constant. We're going to do this. This is okay, right? And then up to this point, we're going to do 5 times 100 t squared and then e cubed. The second, that's a constant e t. Three t e 3 e to the t and then to the third power. And it is right, 6t and e to the 6 to the t. Oh, 1 second, I'm gonna go back and check this. Okay. E to the t, second, So we get 500 t squared and then e to the 6t. 3t to the second is 6t. And it's going to be e to the 6 to the t power. Maybe they want this answer, but I'm double check. Maybe I double check. So 500. Maybe they want a 500 t squared here. E to the 16. That could be. Yeah, it is. So yeah, so we have the right answer all the way. The only thing is they want to put t squared in the first box, right? That's so strange. But it was coded like this, no problem. So for this one, 500 t squared goes in the first box, and e to the 6t goes into the second box. You don't have to redo this, right? It's not necessary. It's all good. Up to this point, it's good. 500 t squared going to first, e to the 6t going to the second box. And let's try next problem. You get this x cubed times x to the 5th equal to x to 8, right? So here n should be equal to 8. This is very straightforward, so I'm just gonna show the answer so we can move on to the next question here. N equal to 8. 3 plus 5 is 8. Right. And next question. Okay, this one is, yeah, this one requires some tweaking, so you try this yourself. Give a shot. Okay, let's go over the solution. So first part, we multiply the fraction and the numbers. Go to the first one, and then put a variable with a together, and a variable with the b together. B to the 7 times b to the 2. Now multiply negative half by 4. Make the fraction, you get 4 over 2, that's 2, negative 2. For the a, combine negative 1 and negative 3. Add them. For b, do the same thing, right? Combine them. Okay, negative 2 times a to the negative 4th, b to the 5th. And this is not done yet. I'm going to make a fraction here because negative exponents are allowed. So we're going to flip this to a denominator. So we end up with negative 2b to the 5th on top. When you flip this to the bottom, it becomes a to the 4th. So it's 2b to the 5th, 2b 5th over a to the 4th. Any question about this? Minus 2b to the 5th over a to the 4th. And submit answers. That's the perfect answer. Yeah, try this one. Right? And let's go over the solution. So multiply 4 and negative 2. And get negative 8. But x will be so 3 times up to negative 7. And using the multiplication property. So you get negative 8 x 3 plus negative 7, right? So it's 3 minus 7. Negative 8x to the negative 4 power. And again, negative exponents are not allowed. So make a fraction, flip this to the denominator, and then you get negative 8 over the 4th. So the answer is negative 8 over x to the 4th. Made it, you get a correct answer. So we're gonna talk about next section now, which is division with exponent a little bit. So let's go back to the note. Let's move on to section 5.2. About divisions with exponents. So let's look at the property. We actually sort of touched on this already. The property for division. So property number 4, right? if let's say we get an x minus a power, so we can turn into a fraction. And now we're gonna flip this to the denominator, and then it becomes on top becomes 1, the bottom becomes x to the a. And that's how we simplify the negative exponent. And we did it with other in the practice. Example 1. If we have 2 to negative 3 power, applying this property with 2 to negative 3 over 1, and flip this to denominator, and then on top of by default is 1, and the bottom is 2 cube. That becomes 1 over 2 cube is 8, 1 over 8. And second example, we have 3 times x to the negative 6. Similarly, we make it a fraction. Now flip this to the denominator. Once we flip it, it becomes x to the 6, positive 6. Any question about this? You try a couple, right? 5, first one, 5 to negative 3. Second one, 5 y squared z to the negative 4. Okay, let's go over the solution here. First one, we need to 5 to negative 3 over 1. Now flip this to the denominator, and it becomes 1 over 5 to the third power. And this becomes 1 over 5 times 5 times 5, that's 25 times 5, 125. And the second one, so make a fraction. And we only flip the negative exponent to the bottom. So we get 5y squared over z to the 4th. Any question about this? Next one, we're going to take a look at property number 5. This one is mainly about the division property. So if let's say we have something like x to the a power over x to the b power. So if we have 2 scenarios. First scenario is the power on the top is bigger than the power on the bottom. Then you do this, you do a minus b and keep it on the top. Second scenario is the power on top is smaller than the power on the bottom. And you do 1 over, so using the power on the bottom minus power on the top, and keep it on the bottom on the denominator. So for example, let's say example 1, if it's x to the 9 over x to the 6, right? Notice that the power on the top is bigger, so you do x9 minus 6, keep on the top. And then it becomes extra first. So that go back to the first property. Second one, if let's say I have something like extra fourth over extra 10th. Now the power on the bottom is bigger. So you're gonna keep it on the bottom and do 10 minus 4. On the top, it's 1, right? And then you simplify after that, x to the 6. So again, dominant power determines the outcome, right? So that's how you gotta be flexible in terms of simplifying this. Well, so you guys try this really quickly. Let's say that's something like x to the 12 over x to the 7. Secondly, you get x to the 3 over x to the 13. And let's simplify this. So first one, the power on the top is bigger, so we're gonna do 12 minus 7, keep it on the top. So x to the second one, the power on the bottom is bigger, so we do 13 minus 3, keep it on the bottom, so 1 over x to the 10. You could do, okay, let me quickly show you. You could do x 3 minus 13, I keep it on the top, but we get to do, we have to simplify afterwards. 3 minus 13 is maybe 10. Now I'm gonna make a fraction and I flip it, and we end up with the same result. Okay. So it's kind of like, in this case, it's kind of easier just using the bigger power minus smaller power, keeping on the bottom. Next property is about distribution of the quotient, right? Property number 6. Let's say we get x over y to the 8th power. I'm going to distribute power a to both top and bottom. X to the a over y to the a. Distribute power to every single element in the quotient. So for example, you have something like x over 4 third. Distribute power on top x cubed. On the bottom 4 cubed. After that, we simplify, so it becomes x cubed over 4 times 4 times 4. That's 64. And also, we have something like this. We have x squared over 2y, something like that. Now, the second power. Now still, right, we're still going to distribute power to both top and bottom. On the top, you get 2 times 2. On the bottom, you get 2 squared and then 1 squared. distribute power to every single one of them. Maybe do this. You do it a little bit slowly, you put it on top. We simplify x. 2 times 2 becomes 4. On the bottom, 2 squares, 4. Take it over y squared. So the extra 4 over 4y squared. And that's how you simplify this. Any question? All right, we try a couple, right? Let's say we have something like 7 over n to the third power. Second one, that 3z over x cubed to the third power. Let's simplify this. Let's go over the solution here. First one, we're gonna distribute power 3 to both top and bottom. 7 cubed over 11 cubed. 7 cubed is 7 times 7 times 7. 39 times 7. 63 and 343, right? Yep, that's right. So 343 over 3 cubed. Second one, distribute the power 3 cubed, z cubed. On the bottom will be x cubed to the third power. So 3 cubed is 27, z cubed over x, 3 times 3, that's 9. That's how you simplify this. And also we have some kind of like special ones. Something like if you have, let's say, x cubed over x squared, right? It's kind of like some special formula. So it becomes x3 or 3 minus 2, so it's x to the first, but it's like the 4 just one x. And also x squared over x squared, because they have the same exponent, we can cancel that and it becomes 1. 1 over 1. Right? So the answer is 1. Also, something like if you have x to the 0 power, that should be 1, right? As soon as x is not 0. So any number to the 0 power is 1. So Similarly, if I say from -a to 0 power, it's going to be 1. And also, it could be a very complicated expression. Let's say 2x squared y to 0 power is 1, right? As soon as x is not 0, y is not 0. And there's some kind of like special operations here. Let's try a little bit more sophisticated ones. For example, let's simplify the following. 5x cubed squared over x to the 4th. And here we're going to apply multiple properties. First property, we're going to distribute power. Right? So it becomes 5 squared times cubed squared. On the bottom here, simplify further, x squared is 25 times x to the 6, 3 times 36, and x to the 4. Now, for the same exponent with the same base, then we're going to combine, simplify, divide them into bigger number minus smaller number, so 6 minus 4, keep it on top. So eventually end up with 25x squared. Any question about this? And we have something like this, x 8 over x squared to the 3rd power. So step 1, we're going to multiply 2 and 3. Carry over x to -8. 2 times 3 becomes 6. Now, negative exponent is not allowed, so we're going to flip it to the bottom. So it becomes 1 over x to the 6 times x to the 8. And if you flip it to the opposite side, it becomes positive exponent. So it's 1 over x. Now, same base, add exponent plus 8, that is 14. Similarly, right, if I say the negative exponent is on the bottom, you could do the same thing, right? I flip it. And similarly, 2 times 3 is 6. On bottom is 8. I can flip this to the top. Then becomes positive exponent, so x to the 8 power. Bottom becomes 1. Now keep the base x, add exponent. And over 1, we just omit it, right? So we don't need to write that anymore. It's not needed. And the answer is going to be x to the 14. And also we have something like, let's say we have 1 to the 5th over 1/3 and to the 3rd power. So there's a couple way of doing this, right? First one is we can simplify within the parentheses first. So we do 5 minus 3. Because 5 is bigger, keep the outside exponent. And 5 minus 3 is square the 3rd power of square. I'll keep the base, multiply 2 and 3. Then we get 6, y equals 6. Okay, any question about this? Next one, a to the 3rd squared times a to the -4 over a minus 4 to the 3rd power. We're going to multiple exponent here. So simplify one at a time, right? 3 to the second, a cubed to the second becomes 8. 3 times 2, 6. Times a to the -4. On the bottom, you multiply -4 by 3, you get a to the -12. Now combine those two, it becomes 6 plus -4, 6 minus 4, 2, over a to the 12, minus 12. Now you can flip this to the top. That works. You can also do 8, because 2 is bigger than -12. You can do 2 minus -12. Using the division property. So 8 is 2 Samaritan is positive, it's 14. So if you flip it, a to the second times a to the 12, bottom becomes 1. And similarly, you combine 2 and 12 with the 14. So same answer, no difference. All right. Any question about this? So actually, we finished section 5.2. Tomorrow we're gonna work on the exercise. So you guys could start working on the homework assignments from. So we just finished substitution. So this 5 sections, right? The 4 sections. Substitution method, which is 4.3, and then application, multiplication with exponents, and division with exponents for tomorrow. Those 4 sections. Okay. And tomorrow we're gonna go over some of the homework assignments from division with exponents. And then we're gonna move on to 5.3, 5.4, 5.5, and 5.6. All right, any questions before we end the class? All right, guys, the next